Okay, girls. Now, the first of the unusual questions in projectiles. Well, this isn't too bad. It's not that unusual, except the original velocity was in a downward direction. So that's why I want to have a look at it. So the question, this is 2016, question 3. It says a ball is thrown from a point A at a target T, which is on horizontal level ground. So T's down here. The point A is 17.4 metres vertically above the point O on the ground. Okay, so this is your starting diagram. It says the ball is thrown from A with a speed of 25 metres per second at an angle of 30 degrees below the horizontal. So this is why we're doing this, because this is thrown down. Okay, this speed is 25 initially. The distance from O to T is 21 metres. The ball misses the target, hits the ground at B. So this is the situation. You've got to find the time for the ball to travel from A to B. So A is the starting position, so you want the time of flight. So remember what your time of flight is. It's the SJ. It happens when the SJ is 0. So that's the first thing. So we start with the IJ table. We'll fill out the relevant vectors. So the starting velocity is U. I'm going to look at it. Here it is, this black line. Remember, if I draw a right angle triangle around it, that will give me the I component and the J component. So the I component is the adjacent to that angle 30 in that triangle. So this is going to be, of course, 25 cos 30. J is over here, the opposite component, but the J is heading down in the negative direction. So this will be minus 25 sine 30. So this is the reason why I'm doing this one. So just watch out for that. Now, the acceleration, of course, is 0 in the I direction, minus g in the j direction. T is arbitrary, which means that V is equal to u plus at. So the u will just be 25 cos 30, and when I put that in I get 21.65. And again, this one will be, when you put 25 sine 30 into your calculator, you get minus 12.5. So again, this is u plus at will give me minus gt, and this is ut plus half at squared. So this is ut, half at squared of course is 0, and this is ut plus a half at squared. Okay, so we want the sj equal to 0, so let's do that. So this is minus 12.5 t minus a half gt squared equals. Now in this case it's not equal to 0 because it's not landing on the same level. So what I should have said here was I'm going to put where the sj is equal to minus 17.4 in this case, because it's falling down below the level of projection. That's minus 17.4 in there. So look, now you have a nice quadratic, and it becomes 4.9 t squared plus 12.5 t minus 17.4 when I sort it all out equal to 0. So I'll use the B formula to get that, and this will give me then t is equal to minus b plus or minus the square root of b squared minus b squared minus 4 times a times c minus 17.4, and that will all be over 2a, which 4.9 will give me 9.8. And when I solve that, you do that, you solve all that off, and you'll find when you do that, that t is equal to 1. Well, of course, we're going to use the positive value. So that's the first part. The second part says find the distance tb. So first part, time of flight. The distance from T to B, this bit here. So if I find the total range and subtract it from 21, of course, that will tell me what the TB distance is. I'll call this, well, this bit's called O, that bit there. So what I'll do is I'll get OB, which is the range. So I'll take OB, subtract it from 21, and that will give me TB. Okay, so the range will be the SI when T is 1, because that's the time of flight. So the SI is 21.65 T. Put in T for 1, and I get, of course, 21.65. So that's the range. That's OB. So 21.65 minus 21 will give me TB, which means that TB, of course, is 0.65. So that's the second bit. And the third bit says, the point C is on the path of the ball vertically above T. So there's a point C which is vertically above T here. That position there is C. Find the speed of the ball when it's at C. So the ball's coming down here, it's passing through C. Okay, so we want the speed, the third part says we want the speed of the ball when it's at this position here, which that position there, when it's at C, look, that's where it is. It's going to be 21 metres out. So we want the speed when the SI is 21 metres. So if we put this time here, we put this expression here, 21.65 T, if we put that equal to 21, we'll be able to find the time when it passes through C. So when you do that, the T becomes 0.97. That's seconds, of course. And I'm now going to find the speed at this time, so the VI plus VJ mod at this time. The VI, of course, is just 21.65, no T affects it, but the VJ is equal to minus 12.5 minus GT. So minus 12.5 minus 9.8 times 0.97. And when I do that, that gives me minus 22J. Right, so my modulus, the speed, the modulus is equal to the square root of 21.65 squared plus 22 squared plus minus 22 squared. That's going to give me 30. When I do that, I get 30.87 meters per second. Okay, so that's the first part, that's part A. So part B of the question. Part B of the question says the plane is inclined at an angle 60 degrees to the horizontal, as shown here. A particle is projected up the plane with initial speed of u, that's this green arrow, at an angle theta to the inclined plane. Okay, the plane of projection is vertical, contains the line of greatest slope. The maximum range of the particle is ku squared over g. So maximum range, maximum is this important word there. It infers that I'm going to probably have to use the drd theta. So that's differentiate the range with respect to the angle. So you've got to find the value of k to 1 decimal place. Okay, so first things first, we'll draw up the table. Okay, so I have all my relevant information in here. G, I'm selecting its two components, and theta, I'm selecting its two components. They're the two vectors that I have to work out. So I've got I and J. Now, I'm going to get U, A, T, V, and S for both of those components. So the I component of the velocity is U cos theta. For the J component, of course, would be U sine theta. A is minus G in the I direction, sine 60, minus G cos 60 in the J direction, T is arbitrary. V is equal to U plus AT, and of course the sine of 60 becomes root 3 over 2. And this one is U sine theta minus G, cos 60 is a half, so that's G a half T. So this becomes U cos theta T minus a half of this, so that will become root 3 over 4 gt squared. This one will be U sine theta T minus a half gt squared, which will become quarter gt squared. Okay, so there are my two sets of components. if I'm talking about range, then I'm looking for the SI when the SJ is 0. So let's put the SJ equal to 0 here. U sine theta t minus a quarter gt squared. Put that equal to 0. This will give me U sine theta t equals a quarter gt squared. Divide across by t and bring over that 4 on the g, and you'll get 4 sine theta over g is equal to t. Right, now the range, the SI at this t. Now this is, we're going to go into a bit of trigonometry now. So the SI is this fella here. So U cos theta by t, and t of course is 4u sine theta over g, minus root 3 over 4g by t squared. So I'm going to square that. That's going to be 16u squared over g squared by sine squared theta. Okay, tidy this all up a bit here. So this becomes 4u squared cos theta sine theta over g, minus that g will cancel into that g squared, and this will become, that 4 will go into 16, 4 root 3, that again over g, u squared by sine squared theta. Okay, look at this here. I'm going to pay attention to this. See, cos theta sine theta. Right, so if I look at my log tables, where are they? Here they are. Sine 2a is twice sine theta cos theta. This is a very common substitution, remember, that we've used many times in class. So I'm going to use it here. So this will therefore become 2u squared over g by sine 2 theta, minus, this stays as is, 4 root 3 over g sine squared theta. Okay, so that's my range. Now I have to find k. Now remember, k is part of the maximum range. So what would this range be if it was a max? So for max r, I'm going to go dr d theta. I'm going to get this dr d theta, and I'm going to put it equal to 0, and that will lead me into a value for theta. Okay, so let's do that. Let's differentiate this. Dr d theta. Differentiate with respect to theta. That 2u squared over g is a constant, so nothing happens there. Right, let's differentiate with respect to theta, sine 2 theta. So that will become twice cos 2 theta, minus 4 root 3 over g is a constant. Now, differentiate sine squared theta, so that will become twice sine theta, and then multiply it by the integral of sine theta, and when you integrate sine theta there, you get cos theta. Okay, now then, this will then give me 2u squared over g, or 4u squared over g by cos 2 theta, minus 8 root 3 over g by sine theta cos theta. Okay, and of course this again is this twice sine theta cos theta, that I should have put that in here actually. That's just going to become sine 2 theta. So this will be 4u squared over g cos 2 theta minus 4 root 3 over g by sine 2 theta. Okay, now I'm going to put that dr d theta, of course, equal to 0, and when I do that, I'm going to put dr d theta equal to 0. So this is my dr d theta. This becomes 4u squared over g cos 2 theta equals to 4 root 3 over g sine 2 theta. I've dropped a u squared there, guys, as I've gone down. So this is 4 root 3. This should be by, I've dropped a u squared up there. Can you see that? So that should be by u squared. I should have a u squared in there, a u squared, a u squared. So this is by u squared. So this will cancel 4u squared over g, 4u squared over g, and I'm left with cos 2 theta equals root 3 sine 2 theta. Sine over cos, of course, is tan. So tan 2 theta is equal to 1 over root 3. Now, 1 over root 3 is 30 degrees. The tan of that is 30 degrees, which means that 30 degrees is equal to 2 theta. So theta is equal to 15 degrees. Okay, so I have my angle when maximum range occurs. I'm going to now find the maximum range, and I'm told what the range is. The range is equal to ku squared over g. So I'm going to put this ku squared over g equal to my range. And the range is this fella here, that one. So I'm going to put that range there and substitute in 15 for theta. Okay, so this will become 2u squared. I'm using this line here now, 2u squared over g by the sine of 2 theta, that will be the sine of 30, minus, this is 4 over g root 3, by the, and again there's a u squared in there, by sine squared theta, so the sine of 15 degrees, and then I'm going to square it. And when I do that, I get 0.07. Okay, so this sine 30 is a half. This will simplify down to u squared over g, minus, when I work this fella out here, put those numbers into the calculator, I will get 0.46 over g u squared. So I'll subtract those and get 0.54 u squared over g. Okay, so this is what my maximum range is. And I'm told that it's equal to that. So that tells me that k is equal to 0.54. And it did say in the question, if you look carefully, it says to 1 decimal place, which means that k would be 0.5. So don't forget to do that little bit at the end.